Hi, welcome to your first video note-taking session for Algebra 1. We're in Chapter 1, Section 1 of your book, and a couple of things that I want you to do before you jump into watching this whole video is I want you to go through the chapter, or go through the section. It starts on page 1 in your book, and I want you to write down all of the important definitions and principles. And also write down any questions that you have if something doesn't make sense or the wording doesn't make sense. Also, I want you to try each example problem without looking at the solution. Once you've worked it on your own, then I want you to compare your work to the solution work. And that's going to be the best way to test yourself and see if you really understand this information before you move on. The rest of this video is going to be going through examples 1, 2, and 3 in section 1. They start on page 2 if you'd like to read along in your book and just see how the example there compares to my own explanation. I like to give you lots of different methods and different perspectives on how you might solve a problem, and so my method might vary just a little bit from the book, which I think is okay. Okay, so we've got example 1. Example 1 has two parts, part A and part B, and you'll notice that the directions ask you to simplify each expression. And so what's really important is to understand exactly what the different words in the directions are asking you to do. An expression, for example, is something that does not have an equal sign. So you might have addition, subtraction, multiplication, division. You might even have variables, but you're not going to have an equal sign. It's just an expression. Simplify means bring this expression down all the way to simplest terms. Again, you can't solve for anything here because you don't have an equation, but you can reduce everything down to its simplest form. So if we're looking at A, I'm going to start by reminding myself of PEMDAS. Right? And I like to write PEMDAS a little bit differently than you might have seen before, just because we've got, let's see, we've got parentheses for the P. Then we're going to look at any exponents that exist. And then we're going to look at multiplication and division. And we're going to read this. We're going to read these from left to right. So even if division comes before multiplication within the problem, that's okay. And then lastly, we're going to look for addition and subtraction. Again, we're going to read from left to right in order to be able to make sure that we get the correct answer. Okay, so now I'm gonna follow by looking at the parentheses first. So the parentheses say that we've got 42 divided by 6. So I'm gonna do 42 divided by 6, which gives me 7, right? And then, according to PEMDAS, I'm going to add or subtract. So I'm going to take this 7 and I'm going to add 8 to it. So we've got 7 plus 8. 7 plus 8 is 15. I'm going to box in my answer. So 15 is this equation, or I'm sorry, I used the wrong vocabulary. This expression totally simplified. Okay, and we're going to do the same thing for part B. What I encourage you to do is to pause the video here and try part B on your own, and then replay the video and see if my solution is the same as yours. Okay, so again, I'm going to be using PEMDAS, and this time I've got parentheses that I've got to take care of before I can do any multiplication or division. So in these parentheses, I've got 8 minus 2. So 8 minus 2 is equal to 6, right? And then now that I have the parentheses done, I'm going to look at the division. So I've got 54 divided by 6. 54 divided by 6 is 9, so 9 is my final answer. All right, so now we're looking at example 2. Example 2's directions are slightly different. It's asking to evaluate each expression given a equals 5, right? So now we're changing from simplify to evaluate. Evaluate suggests that we have a value that we're going to substitute in for a particular variable, in this case A. And then after we make that substitution, then we can simplify, just like in example 1. So, let me get started. We've got 7. Now I'm going to substitute. I'm going to take this 5 here that represents A, and I'm going to substitute it in for this A. So I've got 7 times 5, right? And now this is my new expression, 7 times 5, and I can simplify just as I had for example 1. 7 times 5 is 35, and that is my final answer. Once again, I encourage you to pause in between these two, try part B on your own, and then compare your solution to mine. Okay, what I like to do is to rewrite everything and just simply make the substitution before I worry about anything else. So I'm going to copy everything except for the variable, and then where the A existed, I'm going to put in a 5. Remembering that if I have no operation in between a number and a variable, the operation implied is multiplication. Okay, so now I'm just going to follow PEMDAS and simplify according to order of operations. So inside the parentheses, I have 3 times 5 is a 15, and then add that to 2, 17 is my answer. Okay, so now in our third example, this is the most complicated example of the 3. We've got this expression here, and we're asked to evaluate it if x is 12 and y is 9. So now we have 2 different variables that we're plugging in numbers for, or substituting numbers for, before we evaluate or simplify this expression. Okay, so to start, I'm just going to copy down everything except for the variables. So let's see, I'm going to do 5 minus 3 plus, and then close my parentheses. And now I'm going to take wherever there was an x, I'm going to fill in a 12. And where there was a y, I'm going to put in a 9. And also notice that I just took whatever operation existed between the number and the variable. I just brought that down. Again, recognizing this is multiplication, so change it to multiplication there. All right, now, following order of operations, I have 2 sets of parentheses. Here's one and another. And so I can just actually solve both sets independently in the same line. So 5 times 12 is 60. Bring the subtraction down, and then 3 plus 9 is 12. Now I have 60 minus 12, which is 48, which is my final solution. All right, so that completes the examples for section 1. What I encourage you to do is try the homework problems on your own and bring in any questions that you have to office hours or math lab or sometime during my free period.